This video covers D3 update pattern with key functions. The structure of this video is as follows: D3 update pattern revisited, data join with key function, and the summary. Alright, let's get started. D3 update pattern revisited. When D3 computes a data join using the data operator, three virtual selections are created: the update, enter, and exit selections. The enter selection contains placeholder elements for any new elements. The update selection contains existing elements that have had their data attributes updated. And the exit selection contains the existing elements that have not had their data attributes updated. The data operator joins a specified array of data with the current selection. If the current selection is empty, then we don't have to worry about the D3 update pattern. This is because we are using the normal D3 pattern. However, if the current selection is not empty, then we have to use the D3 update pattern. When we do a data join on a selection that already contains existing elements, we have three scenarios. In scenario 1, we have an equal number of existing elements and data elements to be bound. In scenario 2, we have more existing elements than we have data elements to be bound. And in scenario 3, we have less existing elements that have data elements to be bound. In scenario 1, we have an equal number of existing elements and data elements to be bound. In this case, the update selection will contain elements. The exit selection will be empty, and the enter selection will be empty. In scenario 2, we have more existing elements than we have data elements to be bound. In this case, the update selection will contain elements. The exit selection will be non-empty as there are more existing elements than data elements to be bound. And the enter selection will be empty. In scenario 3, we have less existing elements than we have data elements to be bound. In this case, the update selection will contain elements, the exit selection will be empty, and the enter selection will be non-empty as there are less existing elements than data elements to be bound. Every time we update data and bind it to our elements, we will run into one of the three scenarios. To keep it straight in our heads and in the code, we use the D3 update pattern. This pattern behaves in a way that regardless of what scenarios we are in, the necessary steps are run in order to ensure we are using the correct data. The D3 update pattern is as follows. First, do a data join with the new data. Second, update the old elements as needed. Third, create new elements as needed. Fourth, if the third step appended elements to the enter selection, the update selection expands to include the enter selection, so you can operate on enter and update selections at the same time. Fifth and final step, remove old elements as needed. This way, our code will be easily understandable both by us and others. Using these three strings as datasets, we'll walk through an example in the JavaScript console. First, we'll use the D3 pattern to create SVG text elements where each letter of the string cupcake is an individual text element. Then we'll use the D3 general update pattern to bind the flamingo data. Then we'll use the D3 general update pattern to bind the pony data. This web page has the D3 library imported from the D3.js.org website. We have opened the Chrome Developer Tools and are in the console section. We start with the definition of the SVG container the text will live in. Next, we define the three datasets that we will be using. JavaScript is used to split each string into an array of individual letters. We will use these arrays of letters as the dataset with D3. First, we create the SVG text elements using the D3 pattern and the cupcake variable. We have used the cupcake array of letters to create SVG text elements. Each element has a class of cupcake_enter. Each letter is spaced from left to right according to the index number of the element in the data array. Next, let's do a data update and use the flamingo dataset. Remembering the D3 general update pattern, we will do a data join, an update, an enter, an update, and then an exit. First, the data join. Then, we update the class of the old elements. We can see that all of the DOM elements got their class updated. This is because there are more data elements in the Flamingo dataset than there were SVG text elements. Next, we create new elements using the enter selection. Because the word flamingo has one more letter than cupcake, we will have one element in the enter selection. Remember, once we use the append operator on the enter selection, the update selection expands to include the enter and update selection. Since the update selection has now expanded, we can update the actual text of each SVG text element. You can now see that the text has been updated. To complete the D3 general update pattern, we remove any old elements that did not receive new data. Since there were no elements left over, the exit selection was empty, so no elements were removed. And that completes the D3 general update pattern. Let's run the D3 general update pattern again, only this time with the Pony dataset. First, we do the data join. Then we update the class of old elements. We see the first 4 elements have their class updated to Pony_update. Note that it was the first 4 elements that had their data updated. In D3, unless you specify a key function, which we are going to cover later in this video, the elements are bound first come first served style. Next, we create new elements using the enter selection. Notice that no new elements were created. This is because Pony has less letters than Flamingo, so no new data elements had to be created. D3 just doesn't create any new elements in this case. Remember, once we use the append operator on the enter selection, the update selection expands to include the enter and update selection. Since the update selection has now expanded, we can update the actual text of each SVG text element. You can now see that the text has been updated. The first 4 letters are P, O, N, Y, and the rest of the letters still belong to Flamingo. To complete the D3 general update pattern, we remove any old elements that did not receive new data. You can see that the letters after Pony were removed. We have now seen the D3 general update pattern when we have had more data elements than existing elements in the selection. We have also seen the D3 general update pattern when we have less data elements than existing elements in the selection. In both cases, the data was bound to DOM elements in a first come, first served type of way. That is, the first data element was bound to the first DOM element, the second data element was bound to the second DOM element, and so on and so forth. If we specify a key function in the data join, then the data is bound according to the key function. Data join with key function. The first line is the data operator. The second line is the data operator with a key function. The key function replaces the default by-index behavior of the data join. The key to key functions are that they are used to achieve object constancy. Though they can also be used to improve performance, we will look at them now through the idea of object constancy. Object constancy in D3 refers to how a graphical element that represents data can be tracked visually. This visual tracking refers to any type of transition and, or data joins we can apply to an object. As an object representing data changes, we want to make sure we and our audience can follow the transition from a previous dataset to a new dataset. This makes it easier to understand what is happening and what changed and what didn't change. We now take a look at a famous example of object constancy. This comes from Hans Rosling's 200 Countries, 200 Years, 4 Minutes, The Joy of Stats from BBC4 as seen on YouTube. We start the YouTube video at 1 minute and 31 seconds and will watch to 1 minute and 57 seconds. Each circle you will see represents one country. While watching this video, make sure to follow one of the circles representing one country.
The Industrial Revolution makes countries in Europe and elsewhere move away from the rest. But the colonized countries in Asia and Africa, they are stuck down there. And eventually, the Western countries get healthier and healthier. And now we slow down to show the impact of the First World War and the Spanish flu epidemic. What a catastrophe!
As you were watching the video and following one of the circles, new data was being added to the scatterplot chart. Though new data was being added, you were able to follow one circle all the way through because of the color hue and location. This is what we refer to as object constancy. You were able to visually track a graphical element as its underlying data changed. Okay, so we want to achieve object constancy. How do we do that with a key function? The way we do that is to have the key function return a string to uniquely identify the data point. It is really important to make sure that the string returned will uniquely identify the data point. This way, we can identify which element in the current selection will be getting which data element from the dataset we are using in the data join. This dataset comes from Wikipedia and is a list of cities, their population in millions, and their rank according to Wikipedia. Shanghai is the largest city, and New Taipei is the 50th largest city. The first dataset all, has 6 cities. The second dataset Asia halved, has 4 cities where the population of each city has been cut in half. If we use the by index default behavior of a data join, the 4th element in the DOM would get the New Taipei population name and rank. What we would rather have happen is that each city gets the relevant data update. By returning the name of each JSON object, we can identify the DOM element that has New Taipei as its name, as well as the data element in the dataset that also has New Taipei as its name. Once we have identified both, we can do the data join across these 2 elements. This is why it's very important that the key function returns a unique identifier. Using these 2 datasets, we are going to create a scatter plot. Then we will update the data using a key function. This will help us understand key function data joins better. This web page has the D3 library imported from the D3.js.org website. We have opened the Chrome Developer Tools and are in the console section. We start by defining the 2 datasets. First, we define the dataset with all 6 cities. Then we define the dataset with all the cities from Asia. Next, we define the SVG viewport. Then we define the D3 margin convention parameters. Using the D3 margin convention and SVG viewport, we define the inner drawing space. Next, we define the X scaling function to help scale the population of the cities. Then we define the Y scaling function to help scale the rank of the cities. Now that we have the X scaling function, we create the X-axis and give it an orientation. We also create the Y-axis and give it an orientation. We then call the X-axis function to place it inside of the inner drawing space. We also call the Y-axis function to place it inside of the inner drawing space. And with that, we have our coordinate system to draw our data in. Now we create the circles based on the dataset all dataset inside of an SVG group element with class of circles. Then we define the attributes of the circles. We can now see the circle elements. Next, let's add text to designate which circle represents which city. First, we create the SVG text elements based on the data. Then we add the attributes to the SVG text elements. Fantastic, we now have the city data plotted on a scatter plot. Now, let's update the data using the dataset Asia halved. First, we do a data join where the key function will return the string of the name of the city. Let's check the virtual selections. First, we check the enter selection. This returns an array that is filled with undefined. This is expected as the data we just joined had fewer elements than were already in the existing selection. Next, we check the update selection. The update selection contains 4 elements. As we hover over them, you can see that they represent the 4 cities in Asia. Lastly, we check the exit selection. The exit selection has 6 elements. The first 3 are undefined, then we have the 2 non-Asian cities, and then a last undefined element. This is completely different from what we have seen before. Since we used a key function, the exit elements are found in the middle of the array rather than at the end like they have been before. Let's now remove the exit selection elements. Now, let's update the attributes of the circles based on the data we just joined using the key function. You can see that each circle in the update selection had its CX, CY, and R attributes updated. Since we only changed the population in the Asia dataset, the circles moved to the left. Finally, let's do a data join with the original dataset. Let's check the virtual selections. First, we check the enter selection. We find 2 data elements that did not match DOM elements, so they were added to the selection as placeholder objects. Note that they were filled in using the by index behavior. This is because the key function did not return anything for existing elements, so they were added in as they came in. Next, let's check the update selection. Here we see that the elements in the selection had their data updated. However, we see an undefined X2. This represents the two elements in the enter selection. Next, let's check the exit selection. Since there were more data points than DOM elements in the selection, the exit selection is empty. Let's add in the elements from the enter selection. We choose the enter selection, append an SVG circle for each element in the enter selection, and define the attributes of each circle. Note that the circles for Cairo and St. Petersburg showed up. Lastly, let's update the attributes for all the circles. And there we go. Now all of our circles have updated their data and are located where they should be. Each circle had its data updated correctly because we used the key function. And with that, we have recovered how the D3 update pattern works, as well as covered how to think and do a data join in D3 using a key function. Through the understanding generated, we have continued exploring the general update pattern that we can use in D3 when we are using data that will be updated. The summary. This video covered D3 update pattern revisited, data join with key function, and the summary.